Yeah, okay, I'm going to show you where it comes, from.
Pythagorean theorem.
Comes from Pythagorean theorem. I'll show you why. So find the distance between these 2 points. So plot them. Point 1 is over 1 up 2. Point 2 is over 4, 2, 3, 4, up 1, 2, 3, 4, 5, 6. And you want to find how far is it to walk from point 1 to point 2. And so what you do is you construct a triangle by going over and down, and all of a sudden that's a right triangle, isn't it? What is the base side of that right triangle? How many units is it? 3. So 3 squared plus
4 squared.
Would equal, say, I don't know, d squared for distance, right? Does that make sense? So that's what, 9 plus 16 is
25.
so 25.
Also, if you remember,
It's a Pythagorean triple, yeah. So d is equal to y only positive 5.
negative distance doesn't really make sense.
You can't go negative distance. Yep, exactly. Okay. So, but it's kind of cumbersome to always like have to draw a picture, isn't it? Like every single time you want to find distance, like having to draw a picture. What if your numbers are enormous? It's like, 100 and like 1,000. Does that make sense? Like that'd be like kind of a pain in the butt. So you have to think about where those numbers came from. So that 3, that's kind of like a horizontal distance, right? It came from doing 4 minus 1. Taking this x coordinate minus that x coordinate. Does that make sense? And this other one was 4, and it came from doing 6 minus 2, right? It's like you subtracted the x coordinates, and then you squared it. You took away the y coordinates, and you squared it, and then that you end up getting the distance squared. So let me show you that with a different, like a picture with just letter names, okay? Okay, so put a point right there. We'll call it x1, y1. Hello. Sorry, can't resist. Put a point up there, call it x2, y2. And you want to find the distance between them. And you go the same way, you make a triangle. The base of that triangle is going to be x2 minus x1.
Or vice versa.
If the points are reversed in like where their order is, it would be the other way around. But for now, let's just say in this triangle, it's that one. What would this part be?
y2 minus y1.
And so then you get this formula that says, well then x2 minus x1 squared plus y2 minus y1 squared equals d squared, right? So then the distance is the square root of all that stuff. x2 minus x1 squared plus y2 minus y1 squared. And that's the distance formula. Just to simplify things, I did draw stuff all in the first quadrant, but would that work even if you had a negative number?
Yeah, you're squaring it.
It will, because you square it. So like, for example, if my point had been over there, if I did, in this bottom picture, if I did x2 minus x1, I would be minusing a negative, which will actually end up adding x1. Does that in the end? Well, it'll end up making, the number bigger. So the point is this formula works even if you have stuff that's some negative, some positive. So, and also one thing that matters, because one thing that doesn't matter because you're squaring, technically you also could have written this as x1 minus x2 squared plus y1 minus y2 squared, and that's the same thing. It's because, in one direction you might get a positive, say, 5, the other direction you're going to get like negative 5, but they'll square to the same thing. So the order doesn't matter of the x's and y's.
I heard that you had to make sure that, like, if you're subtracting by the x2, you have to subtract by the y2 too.
Actually, in this particular case, I think you're thinking about something else, which is slope.
Okay.
But in this case, it actually doesn't matter if you were to say, like, do this one this way and the other one the other way,
Okay.
because you're squaring. But there's something later in this chapter called slope, in which it does matter that your order is consistent. Probably it's best to keep it consistent. Yeah.
This one's called the distance formula?
Yeah, it's called the distance formula.
I think we're thinking of the same one, but like the x2 minus x1 over y2 minus y1.
That's the slope.
Okay.
Yeah, that's the slope. Slope is equal to y2 minus y1 over x2 minus x1. That tells you how steep a line is. That's something totally different. Yep. But it's the other thing that has 2's and 1's and x's and y's in it, right? Yeah. Okay. All right, so the distance from between 2 points is distance equals square root. So x2 minus x1 squared plus y2 minus y1 squared. So find the difference in the x's, square them, find the difference in the y's, square them, add them together, take the square root. Remember, yesterday we discussed this is not equal to x2 minus x1 plus y2 minus y1. Does that make sense, what mistake I made there? The square root doesn't distribute, right? Okay. Alrighty, so let's find the distance between these 2 points. So call that x1, call that y1, call that x2, call that y2. So x2 minus x1 squared. Okay. So what goes in for x2?
-7.
Okay, great. So -7 minus 6 squared plus,
-5.
and is it going to be plus 3 or minus 3?
-3.
It'll be plus 3. Why is it plus 3?
Negative distributes.
Yeah, so it's because you're minusing a negative, right? Double negative making a positive. So what's -7 minus 6?
-13.
Great. Plus -2 squared. So -13 squared is,
169.
yep, plus 4 will be square root of 173. If you can simplify, do it. But I would only give you things that were sort of somewhat reasonably obvious if that was expected of you. Like, if your distance comes out to be like root 20, does that make sense? That's pretty obvious. You can make that into 4 times 5, and it's 2 root 5, right? Root 173, I'm not 100% certain, but I don't think that number factors. I think it might be prime, but I don't know. So, but I think it wouldn't be something that, it wouldn't be something that tricky on a test if you had to do it without a calculator or something like that. And if you calculate it, you get an approximate distance of 13.153.
Numbers don't have to be prime in order to
Say that again?
Do we have to find the decimal point?
It just depends. I'm not sure what Alex is going to ask you. Does that make sense? So it's only just so you know that that's what it is. It also is like, with fractions, you can kind of like estimate how large they are, but with square roots, at least I have no concept of how big that number is unless I actually take the square root of the calculator. Does that make sense? But if it was like a quiz question where I didn't give you a calculator, you would just like, leave it. Okay. All right. So that's one formula for distance. Now, a midpoint on a line segment is the point that would be exactly halfway between these 2 points, right? So the midpoint formula, you find the midpoint by averaging the x's and averaging the y's. And that's called the midpoint. We're going to call it M. And I didn't technically prove it because proving is a little bit tedious, but what this number tells you is that the distance from P1 to M equals the distance from M to P2. Does that make sense as a concept? Okay. And you can actually use the distance formula and these coordinates to prove that between like your x1, y1, and this point is equal to your x2, y2, and that point. Just is really a little bit of a pain in the butt. And the kind of amazing thing is that to find the middle, all you do is average the x's and average the y's. It's kind of like super easy, right? About what you'd expect. Okay. So find the midpoint of this line segment, and then plot the points and verify that the distance from A to M is the same as the distance from B to M, and that's half of the distance between the 2 points to begin with. So first, find the midpoint. The midpoint will equal the average of the x's, so 4 plus 1 over 2. What do I add to average the y's?
2 and 6.
2 plus 6 over 2. So that's 5 over 2, or 2.5, right? And 4. Does that seem right? Yeah, okay. And I think that 1, 2, comma 4, 6, those were the points we did in the very, very first page. I picked that on purpose to redo the distance formula. 1, so we had 1, 2, 4, 6. So 2.5, 4. Does that appear to be in the middle? Okay. But how we're going to actually verify it is we're going to find the distance from A to M, and then the distance from B to M, and show that they're equal, and the distance from A to B is half that much. Or half of that is the distance between, half of the distance between A and B is this number. So apply the distance formula with point A and point M. So that's the root of what? x2 minus x1 squared, y2 minus y1 squared. So what goes in for x2?
2.5.
2.5, great. Minus x1 will be 1. And then y2 is 4 minus 2 squared. So we're taking this one to be our 2's and that one to be our 1's.
Why did we use, because we're using the point, midpoint that we got.
Yeah, what we're doing is like proving to ourselves that it actually is the middle. Does that make sense? So the way to prove it's actually the middle is to find the distance from the first point to the midpoint. Does that make sense? And that's what this is doing. Then we're going to find the distance from the second point to the midpoint, right? And then we're going to show that they're the same number and it's equal to half of the total distance. So what is that? It's root, that's 1.5 squared, right? Plus 4, which ends up being the square root of 6.25, which is 2.5. Question, is this half of the total?
Well, we did it.
We did this in the
same numbers and it was 5.
We did in the first example. Does that make sense? The total distance was 5, so yes, that is half the total, right? So let's verify the other points right by finding distance from B to M. So square root, and so we'll just say that, B is x2, so that would be 6 minus 2.5 squared. Did I do that right? I did that wrong. What should I have had instead? 4, thank you. So sorry, I don't mean to be extra confusing. 4 minus 2.5 squared plus 6 minus 4 squared. It's going to be the same thing, isn't it? 1.5 squared plus 4, so we know that's going to be 2.5. So yes, you got the middle. So that verifying stuff's a little, it's just asking you to check that and make sure that you understand that when you find a midpoint, the distance from your first point to the midpoint equals the distance from the midpoint to the second point, and that both of those are half the total. That's all it's asking for. Okay. This next question is a little bit trickier. So if you have a midpoint and you know your first point, you want to find the coordinates of the second point. Yes?
I had a question on the other one.
All right, so in this one, I have a point, and I have the middle point, and I want to find the other end point. Does that make sense? So in my midpoint formula, my first coordinate is x1 plus x2 divided by 2. My second coordinate is y1 plus y2 divided by 2, right? Does that make sense? Okay. So I know that x1 is -1 and x2 is -5. Crap. I'm so sorry. I know x1 is -1, and what is -5? y1. Okay. So then, does it make sense that -1 plus x2 over 2, what's that going to have to equal? That gives you the x-coordinate of your midpoint, right? What is the x-coordinate of your midpoint? 1. Does that make sense? Okay. If I say -5 plus y2 over 2, that gives you the y-coordinate of your midpoint, right? And what is the y-coordinate of your midpoint? -1. So the thing is, you didn't know the 2 points that were added together. You knew one of the points and what the answer was. Does that make sense? That's the difference here. And then you have to figure out what the second point was. Both of those equations aren't ridiculously difficult to solve, are they? Unless your brain turned off because they think it's Friday early. So how do you solve the first one for x2? So we'll have -1 plus x sub 2 equals 2. And so what's x2 going to equal? 3. This next one will be -5 plus y sub 2 equals -2, and your answer for y2 is also 3. So your point B is equal to 3, 3.
I have a lot faster way. You can just find the x's and then find the y's and then just add it to the midpoint.
Find the x's,
Here, I'll show
find
you.
the
It's a lot easier to
y's.
see.
Relying on a picture.
Yep.
Yeah, but then if you'll draw a picture, which isn't always possible. I mean, it's
not-
always possible, but
I know it's, but you can write it in a different way as well. So what was our
so we had -1, -5.
That's 1, 2, 3, 4, and that's 5.
And the other point was 1, -1.
Okay, so you go over 2, and you go up 4. So you can just do that again.
That works too, yep. So
And
what he's
that's-
doing is using the Pythagorean theorem twice. So he's saying that if you make a triangle here, you get this distance. It's over 2 up. You said 4? The only problem with your method, well, it does work, is that it doesn't work super well for stuff when it's decimals and things like that. But it works too. So if you want to use the geometric thing, that's also totally fine. So say from the midpoint you go over 2 and up 4 and it gets the same result. Does that make sense to the rest of you? Okay, so that's also a possibility. Okay. I like equations because I like algebra better than geometry, but that's just me. So, okay. So write an equation for all points that are 5 units from the origin. Graph your equation. So we had that question yesterday where we graphed a circle, right? And it's kind of like, accept the fact this is a circle, just go with it. So the definition of circles actually comes from the distance formula. Circles are special, they're a set of all points that are the same distance from a specific point, right? So with a circle that is, all points are 5 units away, so I have 1 point xy, and I have 1 point 0, 0. And what this says is that the distance between them, so x minus 0 squared plus y minus 0 squared, what is that going to always equal if we're always 5 away? It'll always equal 5. So I have the root of x squared plus y squared equals 5. And technically speaking, that doesn't give you everything, that just gives you the top half of a circle. So this is often written like this: x squared plus y squared equals 25. And this is a circle with r equals 5. So the thing you can tell is that the radius is always the square root of that number. Does that make sense? And I think the best way to plot things of radius 5 is to first find the center, which in this case is the origin, and go 5 to the right, 5 to the left, 5 up, 5 down, and try your best to make it circular-ish. I'm not going to grade your art, but if you make a diamond, I'm going to judge you a little bit. I had students who would do things like they would literally draw this, and I mean, I'm sorry, but like that just doesn't make me believe you think it's a circle. Like, try to make your sides curved, okay? Yes?
When it says circles up at the top of it, and then it says 5 units from the origin.
That's
then
the thing.
I just kind of assumed that it was a circle and 5, I just put the points.
That's okay.
Points and drew a circle.
That's
So we're
okay.
supposed to write.
The point is that geometric definition results in a circle.
Oh.
Does that make sense? And so the geometric definition of being always 5 points away means you're definitely going to be a circle. And then the distance formula tells you that the equation of said circle is like this. Does that make sense? Yeah. So what would it have been if it would have been a circle of radius 2? What would the equation have been for? It would have been x squared plus y squared equals 4. And that's just also being centered at the origin, right? What if it had been a circle of radius 10? X squared plus y squared equals 100, right? Okay. All right, now in general, I don't know if you graph circles in earlier classes, but not all circles are centered at the origin. Some of them are like kind of move left or right or up or down. So here is the more general formula for a circle. So a circle is the set of all points in a plane that are equidistant from a fixed point. The fixed distance, what's the fixed distance called? It's called the radius. And the fixed point is called the center. In our previous one, the center was the origin. Does that make sense? Okay. So the center has special letters. The center is always denoted by H, K. And the radius, of course, that one makes more sense. That's equal to R. Is that okay so far? And how we're going to show, I'm going to show you that the formula for a circle comes from the distance formula, okay? So you have any other xy. So for any other xy, so here's your distance formula, x2 minus x1 squared plus y2 minus y1 squared. For any other point on the circle, what is the distance between that point and the center? How far apart will they always be? They're always going to be r away, so it's going to be r equals square root. So x coordinate is just plain x minus h, whole thing squared, y minus k, whole thing squared. Does that make sense? So I'm just plugging in xy for x2, y2, and I'm plugging in hk for x1, y1. Or without the square root sign, that's the same thing as x minus h, the whole thing squared, y minus k, whole thing squared, equals r squared. So that's the equation for a circle with center hk, radius equal r. Does that make sense? Okay, so that comes from the distance formula. That's why it is what it is. Okay, so let's find equations for some circles that have centers in certain places and certain radii, okay? So, oh, wait, what? Oh, I just did that, okay. Okay, so find an equation of a circle with this center and with that radius. So the general equation is x minus h squared, y minus k squared equals r squared. And the h and the k are the coordinates of the center. So the equation for this first one's going to be x minus 3 squared plus y minus negative 2 squared equals 4 squared. Does it make sense why the numbers went where they went? Okay. Can you simplify that just a little bit? I don't want you to expand it. I don't want you to multiply stuff out. This is kind of the most useful form, but what I'd like you to do is say, make it into y plus 2. Does that make sense? And just say 16. But you don't have to do x minus 3 times x minus 3 or y plus 2 times y plus 2. This form is actually the most useful for circles because you can look at it and say, oh, my center is 3, negative 2, and my r is 4. When you expand it out and multiply, you lose some of that information. Okay, so how about the next one? We're going to have x minus squared plus y minus 3 squared equals root 5 squared. So that'd be x squared plus the quantity y minus 3 squared equals 5, right? So that circle has radius square root 5, which is just a weird number. So does it make sense? We took centers and radii, made equation. How would you take equation and extract the center from it? So for example, look at the next problem. That's what you're supposed to do. You say, I gave you this equation. What's the center? What's the radius? So what is the center for this guy?
5, 0.
Uh-huh. 5, 0. It makes sense that you don't look at the negative sign, right? And what is the radius? Exactly. Those problems on Alex should take you all of 10 seconds. Maybe 30 to typeset your answer in, right? What's the center for this guy?
5, negative 7.
5 minus 7. And the radius?
Root 15.
Which doesn't simplify, right? Okay, so those, not so bad. Now, if you multiply stuff out, you kind of lose information where the center is and where the radius is. And this is another time when you complete the square to go back. So it's pretty clever. So here we go. First thing we're going to do is we're going to group the x's in sort of next to each other and put the y's next to each other. So write this as x squared minus 8x plus y squared plus 10y equals minus 25. We're trying to make it into x plus or minus something squared, and the way to do that is to complete the square. So you complete the square with the x's and then with the y's. So what number would you add to the x's? You guys remember? 16. Great. And if you add 16 to that side of the equation, math is fair, right? So the other side also gets a plus 16, right? And how about with the 10? What number do you add with that one? 25. Remember, it's half of the 10 squared. That side too. And once you've added those numbers in, how does the first underlined piece factor?
X minus 4.
Mm-hmm. X minus 4 squared. How about the next one?
Y plus 5.
Mm-hmm. Squared equals,
16.
And once you've converted it into that form, can you now find the center and radius?
Yes.
So what is the center?
4, negative 5.
And the radius is,
4.
mm-hmm. So completing the square has lots of things that can be applied to, and one of which is sort of making stuff back into a form you can easily interpret. Have you guys ever graphed parabolas, like in an earlier math class? So another application of completing the square is making parabolas a lot easier to graph. Did you learn how to graph stuff by shifting things left and right and up and down ever? Maybe a little bit. And so if you know how to complete the square really well, it can make parabolas really easy to graph by making them back into something you can shift left, right, up, down. It's a really great trick. Yeah.
So when we're looking at, like, usually if we're given this equation, we'll have instructions like it says above. Otherwise, like, my initial reaction would be to pull out the common, like, pull out the x to do the grouping.
Exactly, and this doesn't get you anywhere. Like it's not like it's wrong, but it really won't tell you the radius. Does that make sense?
So we just have to know that it's.
You have to know that, yeah. And so I think the hint is that this equation for circles that's very easy to tell the center and radius from involves stuff squared, right? So what you have to think to yourself is that to make something into stuff squared, the technique is to complete the square. Like that's what does that. Okay, so notice how the one on the left had both an 8x and a 10y, right? The one on the right doesn't have a number with an x. Does that make sense? So yeah, so that means that this thing is already completed, or that the x coordinate is going to be 0 of the center. So the only part you have to complete there is the y part. So you add in 16, and you add in 16 there. So that's going to be x squared plus, how does that thing factor?
1 minus 4.
Squared, great, equals 25. And as long as you complete the square correctly, the resulting thing you're going to get will always be something squared, right? Hence the complete the square name. What's the center for this one? And then what's the radius? 5. Great. That's kind of the hardest that circles really get.
How would you graph an oval?
You have to click a division.
How would you graph an oval? So I think you're thinking specifically about ellipses. That formula, I'm not even sure if it's part of this class. Like my Algebra 2 students did it in high school, but I don't think that conic sections and that specifically is in this class. But it's not ridiculously hard, and it's kind of similar to a circle. So at the end, when I finish the lesson, I'll show you how to do it, okay? Alrighty. So now we're just going to go find some circles' equations given various information about them. So find the standard form of the equation of the circle that has a diameter with these endpoints. So, well, phooey. They did not tell you the center, right? What else did they not tell you? The radius. That was so mean of them. And by them, I mean me. Okay, so let's just at least graph it and look and see what we got. We got negative 6, 0. So back 1, 2, 3, 4, 5, 6. And 0, negative 8, down 1, 2, 3, 4, 5, 6, 7, 8. And there's some kind of circle going on there. And I know I didn't draw it perfectly, but that is the diameter. Does that make sense? So if that is the diameter, does it make sense that the diameter goes through the center? Does that make sense? And so the midpoint of that of those 2 points is going to be the center. So midpoint equals center. So to find the midpoint, where that's x1 plus x2 divided by 2, y1 plus y2 over 2. So I think that's -6/2, comma, -8/2. Does that make sense? You got a nod if you think so.
Yeah.
Yes, thank you. I can't read your minds and I don't want to. -3, -4 is my center. Okay. Yeah.
When you said that the midpoint equals center, did you mean like the radius or center of the circle?
No, I mean like the midpoint of these 2 points is going to be the center, but the radius also comes from that. So I think you're just thinking about the different thing. I think what you're thinking about is that the half of the distance is going to be the radius. Does that make sense? Is that what you were thinking? Because what you need is you need a center and a radius to give an equation of a circle, right? And so these, you were told that the diameter of your circle was like through those 2 points. So you take those 2 points and you connect them, that's the middle of your circle. And that means that this middle point between them has to be the center. That's the midpoint. And then the radius will equal half of the distance from -6, 0 to 0, -8. Does that make sense? That's what I was getting at.
You could also do the center and then.
You could also do the distance from one of the points to the center, and that would be the radius as well. Because these points both contain zeros, I think using them and halving it is easier. Does that make sense? But you're totally correct. So r will equal 1/2 square root x2 minus x1 squared plus y2 minus y1 squared.
So we're doing it's half and then the distance formula.
Yeah, exactly. Or you could say, you know, r is equal to, what I was saying is r was 1/2 d. Does that make sense? Okay. So that's going to be x2 is what? 0, right? So 0 minus -6 squared plus -8 minus 0 squared. I think that's half of, what, 36 plus 64? Someone tried to make this work out nice.
Would be 164.
Say that
Would
again?
be plus, never mind.
Okay. 100, so half of 100, half of then 10, right? So your r is equal to 5, right?
So what I did was I did the distance from the midpoint.
And then you would have gotten 5 right away. Is that
Yeah.
correct?
I got 5 as well.
Exactly. So -3, -4, and that's your r. So I know that was a little bit tedious, but what's the equation?
X plus 1, X plus 3.
Uh-huh, squared plus,
Y plus 4.
uh-huh, equals 25. So with that question, my point was that the radius and the center were kind of hidden in the information that they gave you, right? Okay. Alrighty. So the same thing is kind of true with the next one. So find the standard form of the equation of a circle that has this center and passes through this point. So you can actually do this lots of different ways. So I'll show you my way, but there are other ways that you might think of that are different than this. So when I would first see this, I would say, oh, well, I at least have x plus 3 squared plus y squared equals r squared. Does that make sense? You don't know what r is, but you know you got that. There are lots of ways to find r. One way would be to find the distance from -3, 0 to 6, 1, right? Does that make sense? That would give you your r. What would be another way to find it?
You could reduce it.
Reduce. What do you, just be more specific. What do you mean by that?
Okay, so, if you graph it, it's like over,
Okay, so,
So it's over the
okay, so you want to graph it, okay, that's a fine thing.
Yeah.
Here's what I was thinking, that point is an x and a y, isn't it? Can't you plug those numbers in for x and y and solve for r? Does that make sense? So as in you could say, well, 6 plus 3 squared plus 1 squared equals r squared. And so that's what 9 squared is 81, right? Plus 1 equals r squared. And so r is equal to square root 82. So this is an instance where graphing really wouldn't let you find the r because the r isn't like a nice whole number. Does that make sense?
Yeah.
Okay. Yes.
So because it says it passes through it,
Mm-hmm.
it's in the middle of the circle doesn't count, so passing through would mean that it's the same. That's why you said the distance, you can find the distance from it. It's because it's.
Because the distance from the center to any point is always the same. It's always the radius, exactly. Yep, that's a great question. So that would be the equation of the circle then, right? So those two methods make sense? Yeah.
Isn't that supposed to be x plus 3 squared?
Yes. Thank you. And actually, I think finding that, like, if you do find the distance, you would do the square root of 6 plus 3 squared plus 1 squared, right? That's the exact same expression that shows up there, isn't it? It's just already square rooted. Yes.
Sorry.
It's okay. No, it's fine. Go ahead.
The other question I had is, all the questions asked for, which I guess you'd have to be careful, otherwise I would have just found the radius and just left it like that.
Yeah.
They all ask for a standard form of the
Mhm.
equation.
So that's what that is.
Okay.
Yep, exactly. That's what that is. That's called standard form for a circle. So it's the whole x minus h squared plus y minus k squared equals r squared. Yep. If you just gave me the radius, like, I probably wouldn't dock very many points if it was like a quiz or something. But that's the other good thing about computer systems is that they tell you that no, they want you to give a circle. Does that make sense? I think Alex is even smart enough to tell you that you're sort of wrong in a right way. Sometimes. Does that also make sense? Like he'll say, oh, keep reducing or simplify more, as opposed to like you're completely freaking wrong. Yeah. Okay. Some of you have graphing calculators, right? Like in your possession or something. Or you could steal one from a friend, right?
Yeah, not right now.
Not on you right now. But the point is that if you have a graphing calculator, graphing calculators don't graph stuff when it's not solved for y. Like you have to have y equals something. Does that make sense? So certain graphing apps, like I have an app, well, it's actually a default program on my Mac, that if I type that equation in as is, it gives me a circle. Like I can type it in without it having to be y equals something. But if you have to graph that on a calculator, what you have to do is solve it for y. Okay? So if you solve that for y, as in get the y by itself, does it make sense, first of all, that y squared equals 25 minus x squared? And then y equals, this is not quite right. What do you need in front of that because you square rooted? Plus or minus. And you see how that's actually two equations? The first equation is positive square root 25 minus x squared. So we'll call that y1. What's the second equation? Negative, same stuff. And what that first equation is, that's going to give you the top half of the circle. What's the second equation going to give you, you think?
Bottom.
The bottom half. The negative sign means all the y's are negative. And then together, they'll make your whole circle. So pretend that I could actually draw, all right? Just imagine for a second. And this is something that does come up in calculus. I can even tell you what chapter and what section. It's section 5-3. But you have to be able to look at this equation and say, oh my gosh, that's the top half of a circle, or it's the bottom half of a circle. You have to recognize that that is what these equations mean. Does that make sense? So look at the next ones. Tell me, is it the top or bottom half, and what's the radius of the circle? It's like this one. Would it be top half or bottom half? Top half. And what's the radius of this thing? 2. And its center is at 0, 0. And the only ones I can think of that come up in calculus are the ones that are like this and centered at 0, 0. What's this one gonna give you?
Bottom.
Bottom half. The radius will equal 10, and the center is once again 0, 0. Just drawing a picture, this first one's gonna be -2, 2, 2.
What would
And
the
this-
equation look like if the center wasn't at 0, 0?
Okay, let me draw these and say one more thing, that'll answer your question, okay? It's a good one. And what you'll have to do in calculus is find the areas of these things. So what would the area of that one be?
2 pi r squared.
The area of a
divided by
circle is pi r squared. You're thinking of circumference.
2. Okay. pi
But
r
because you have half a circle, you would need a
Absolutely.
half there. So that would be 1/2 pi times 4 or 2 pi. Hey, by the way, when you were little, and your teacher said, oh, the area of a circle is pi r squared, did anybody say, like, why? Anybody ask their teacher, like, why that's true?
Yeah, I forgot.
Okay,
Does it
but
have something to do with the radians?
the reason it's true is because of calculus. Like, you can prove the formula is what it is, and you use calculus to do so. So, but the radians, we're gonna do radians later, something totally different. That has to do with circles, sort of, but not quite. Now, this one, what would the area be? It'd be 1/2 pi times 10 squared, right? So that'd be, I think, 50 pi. And the thing you're gonna do in calculus is this area, because it's below the x-axis, is called assigned area, and it's gonna have negative area. So you say, like, area that's below the x-axis is negative and above is positive, kind of a thing. So, that's,
for me to understand.
So if it was a full circle, then technically there would be 0 because the negative and the positive would cancel each other out.
yeah, there, and stuff like that happens as well, definitely. Yep, yes.
Now, I've heard of a way to mathematically prove that pi is equal to 4, and I've not come up with a way to disprove it. If you cut the corners of a perfect square by, say, 1,